Welcome back to another OpenDSS-G lecture. I'm Davis Montenegro, the creator of the tool. Today, I want to walk you through some of the updates we've made to the graphical interface. These improvements are all about making the visual workflow faster and narrowing the gap between scripting and graphical circuit modeling. To show you how these changes come together, I'll use the circuit description example from the user manual. Let me go ahead and open that model so we can dive in. In this example circuit, we're working with a simple radial system. We have a substation transformer stepping the voltage down to 12.47 kilovolts, 3 line segments, 2 loads, a capacitor, a voltage regulator, and a generator sitting at the end of the feeder. For this exercise, the goal is to build out the circuit in two ways. First, using the graphical tools, and then using the scripting interface. One of the biggest changes in OpenDSS-G, especially in version 7, has to do with how buses are handled. In standard OpenDSS scripting, buses aren't objects you create ahead of time. They're just reference points, and they're generated automatically whenever you declare an element that connects to them. Historically, OpenDSS-G required users to create bus objects manually, which made the graphical workflow feel a little bit different from scripting. Version 7 closes that gap. Now when you draw or place an element in the schematic, you don't need to create the bus first. Just like in scripting, the bus is created automatically as soon as the element is defined. Alright, let's get hands-on and start by declaring the substation. In the user manual, you'll find all the parameters we need for this step. The substation is modeled as a 115 kV voltage source delivering power at its nominal voltage. To create it, head over to the PC element subpalette and select substation, just like you see on the screen. Once you place it, go ahead and enter the parameters listed in the documentation. Next, let's declare the bus that the voltage source connects to. Go ahead and double-click the Bus 1 property. You'll notice that the bus selection dialog looks exactly the same as before, but right now the list is empty, because we haven't created any buses yet. Instead of trying to pick one from the list, just type in the name of the bus you want. OpenDSS will create it automatically. After that, set the connection sequence, which tells OpenDSS-G to include the new bus when the element is declared. Once that's done, click Create. This adds the voltage source to the OpenDSS model and makes it appear on the GUI. You'll see that since the element has only one bus, OpenDSS automatically inserts a switch connecting it to another bus. That's mainly for visualization. You can choose to use the second terminal of that switch or ignore it entirely. In our case, we're going to use it. The additional switch creation only occurs when a PC element is declared connecting to a non-existing bus. Now let's go ahead and declare the substation transformer. This is a 3-phase step-down transformer and will follow the parameters listed in the user manual. When you get to the bus's property, you'll see the familiar bus selection dialog. This time though, we actually have some buses available. We'll pick one of the existing buses for the transformer's primary side, and then we'll type in a new name for the secondary bus so OpenDSS-G can create it automatically. Once all the parameters are filled in, click Create. That will add the transformer to the model and update the schematic right away. We'll follow the same approach for declaring the lines, starting with the line codes. A line code is basically a reusable object that stores the electrical characteristics of a line. Think of it like a small library entry you can call later. Using line codes saves time because you don't have to read the same parameters every time you create a new line. Once the line code is set up, we can go ahead and declare the 3 lines in the model. The process for assigning buses is exactly what we've been doing so far. Choose an existing bus for terminal 1, then type a new name for terminal 2 so OpenDSS-G can create that bus automatically. As you add each line, you'll see the schematic update right away, along with the underlying OpenDSS model. At this point, we'll follow the same process to declare the remaining elements: loads, the capacitors, the regulators, and the generator. All the parameters you need are listed in the user manual as shown on the screen. Since we've already connected most of the power delivery infrastructure, the necessary buses are already in place. That means that new PC elements can simply connect to the existing buses unless you introduce new lines or transformers. Once you finish declaring these elements, go ahead and turn on the element display heat map. This will highlight where each element is located in the GUI. Once we've updated the voltage bases through the simulation configuration menu, we can move on to declaring the monitors listed in the user manual. Since we're working graphically, we'll use the meter manager for this part. In earlier versions of OpenDSS-G, you had to save your project before switching into simulation mode. That workflow turned out to be a bit restrictive, so in version 7 we added guardrails that make things more flexible. Now, as long as you have a circuit model loaded in memory, you can jump straight into simulation mode without saving first. So let's switch over to simulation mode and define the monitors exactly as they're described in the user manual. Alright, now let's run a simulation and pull a few values just to confirm everything is behaving as expected. With that, we've completed the full graphical workflow for building a circuit from scratch. Now that you've seen the GUI approach, let me walk you through the exact same exercise using the scripting tool. In the scripting section of the user manual, you'll find the exact same circuit we just built, this time written out as a script. Go ahead and copy that script into the OpenDSS-G scripting tool, just like I'm showing on the screen, and run it. That will recreate the entire circuit model automatically. After that, you can use the topology estimation tool to clean up the layout, and then run a simulation. You'll see the results match exactly what we obtained with the graphical workflow. As you can tell, scripting can speed up the circuit building process quite a bit, but the nice thing is that both approaches are available, so users can choose whichever method fits their workflow best when creating or editing OpenDSS models in DSS-G. And that brings us to the end of this brief session. I hope you found the walkthrough clear and helpful, and I'm looking forward to having you join me in the next lecture. OpenDSS-G has grown into a flagship platform for exploring and showcasing the full power of OpenDSS, and for more than a decade it has helped thousands of users learn, experiment, and innovate through an intuitive graphical experience. Each year we push the boundaries of what a graphical interface for OpenDSS can be, bringing the engine's advanced capabilities to life with richer visualization, smarter workflows, and tools that can accelerate both research and real-world engineering. To amplify that momentum, we've introduced the OpenDSS-G roadmap, a dynamic community-driven space where users can vote for upcoming features, propose new ideas, and engage directly with the development team. It is designed to make your voice central to the evolution of the platform and to ensure OpenDSS-G continues to meet the needs of utilities, researchers, consultants, and innovators across the industry. As an open source project, OpenDSS-G thrives on collaboration. We invite users to share their perspectives, help shape priorities, and, if interested, join as contributors to advance the next generation of graphical tools for power flow simulation based on OpenDSS. Visit opendss.prodcom.com to start your journey helping to shape the future of OpenDSS and OpenDSS-G. Thank you.